Welcome back to the Explainer. I'm absolutely pumped for this one because today we're tearing down a major wall in enterprise architecture. We're moving way beyond traditional retrieval-augmented generation, or RAG, and looking at an entirely new paradigm for answering those massive, complex questions across your vast document repositories. So let me ask you, have you hit the RAG ceiling yet? Picture this. You're at a private equity firm, right? You're doing due diligence on a $500 million acquisition. You have to analyze financial statements across 12 different subsidiaries spanning 5 years. You're digging through over 200 supplier contracts plus environmental compliance reports. If you ask a standard RAG system to consolidate financial risks based on all those current supplier terms and pending litigations, it's just going to fail. It pulls fragments based on lexical similarity, sure, but it completely misses those vital cross-document connections. To fix this, here's our game plan for today. We'll start with the RAG ceiling, then break down task-aware compression, look at multi-rate compression tiers, map out the AWS serverless architecture, and finally, figure out how to choose the right approach. Let's jump right in. Starting off with Section 1, the RAG ceiling, and exactly when similarity search falls short. Here is the core issue visualized. On the left side, we know standard RAG is fantastic if you're looking for a specific needle in a haystack. It uses similarity search to pull those top chunks of data perfectly. But honestly, it operates totally blind when it comes to the big picture. Now look at the right side. This is what enterprise queries actually demand. We're talking cross-document reasoning, holistic synthesis, and connecting dots between hundreds of documents that might share absolutely zero lexical similarity. Basically, we don't just need the needle, we need a way to look at the entire haystack all at once. That brings us to Section 2, Task-Aware Compression, which is a completely new paradigm. Enter Task-Aware Knowledge Compression, or TAK for short. The brilliant part here is that instead of searching raw documents at query time, TAKC uses a large language model to produce much shorter, highly task-focused summaries of your entire documents completely offline. You see, generic summarization tries to cover everything, which just dilutes your information density. But TAKC compresses documents through the lens of a highly specific task. It literally gives you access to your entire knowledge base in a compressed form, so you preserve all those vital cross-document connections that standard RAG just drops on the floor. Let's make this concrete with our private equity example from earlier. You start with the exact same source document, like an annual report. If you compress it through a financial lens, the LLM pulls out exactly what you need for that: revenue, margins, and cash flow data. But if you run that very same report through a compliance lens, the output is completely different. It's pulling regulatory citations and violation histories. You're compressing once per document per task. You keep exactly what matters for that specific analysis and literally discard all the noise. Moving to Section 3, multi-rate compression tiers and matching fidelity to complexity. Now this matrix right here, this is the actual engine of the architecture. TAKC doesn't just do one-size-fits-all. It maintains 4 distinct compression tiers for each task type. A query complexity analyzer looks at your incoming question and transparently routes it to the perfect tier. So if you need multi-step cross-document reasoning, you get routed to the light tier. That gives you an 8x compression, retaining the most context. But what if you're just doing a quick factual lookup? The system instantly routes you to the high or ultra tier, which reduces the context by up to 98.4%. And here's a fun fact. Most enterprise queries actually hit these ultra-compressed tiers, which saves you a massive amount of context budget. Let's look under the hood in Section 4, the AWS serverless architecture and its dual pipeline engine. Okay, first up is the asynchronous ingestion pipeline. When raw data lands in Amazon S3, boom, it triggers an event. An AWS Lambda function immediately jumps in and chunks that document into 256 token segments. It uses a 50-token overlap too, ensuring absolutely zero information is lost at the boundaries. Then it asynchronously calls Amazon Bedrock, passing in those task-aware prompts we talked about to compress the chunks across all 4 tiers simultaneously. Finally, these pre-compressed representations are stored neatly in Amazon Elasticache serverless. And remember, all of this heavy lifting is happening entirely offline. Now, contrast that ingestion process with the query pipeline. When an authenticated user asks a question, Amazon Cognito handles the JWT verification, passing the request safely through API Gateway and WAF. Then, a Lambda function kicks in to analyze the query's complexity using heuristics. It quickly reaches into Elasticache, grabs the pre-compressed context for the correct tier, and sends just that lightweight context over to Amazon Bedrock for incredibly fast, highly cost-effective inference. You'll notice there is zero expensive, real-time summarization happening here. It is blazingly fast. Finally, Section 5, choosing the right approach, looking at the data payoff and decision matrix. So here is the real magic number and a massive token cost reduction. Think about this. If you have a knowledge base of 100,000 tokens, standard RAG might end up pulling 10,000 tokens worth of chunks to answer a query. But with TAKC operating at that Ultra 64x compression tier, your query drops to a mere 1,563 tokens. That is a staggering reduction in input costs, happening day after day, query after query. If you're managing large enterprise knowledge bases, this is exactly the kind of math that will make your CFO absolutely love you. Of course, engineering is all about trade-offs. It's not really about choosing one approach over the other exclusively. It's about knowing exactly when to use which tool. This decision matrix lays it out perfectly. If your knowledge base is relatively stable, say changing daily rather than hourly, and your queries demand cross-document reasoning across the full corpus, TAC is your clear winner. However, if your data is highly volatile and changes by the minute, or if you have super strict compliance rules that require an exact audit trail back to a specific, uncompressed source document, you absolutely still need RAG. In the real world, the smartest architectures are deploying a hybrid. Let TAC handle the deep, complex analytical synthesis, while RAG fetches the exact supporting documents when you need that strict audit trail. We've covered a ton of ground in this explainer, right? From hitting the ceiling with standard RAG to unlocking the incredible power of task-aware multi-rate compression. But grasping the theory is really only half the battle. The best part is that AWS has made this reference implementation fully open source. So my final question to you is this. Now that you have the blueprint, how are you going to re-architect your knowledge bases using the TAKC AWS GitHub repository to finally answer the complex queries your business actually needs? The tools are right there. The CDK stack is literally ready to deploy. It's time to go build. Thanks so much for joining me today, and as always, keep learning.